Assalamualaikum guys, welcome back. Okay, so now we are going to talk about the reaction of the elements with chlorine. Okay, we did the reaction of the elements with oxygen. Now let's talk about the reaction of elements with chlorine, and these equations are also important, including this diagram that you guys can see over here, because you are asked to draw the diagram as well, and you are asked to write down the equation of, let's say, aluminum with chlorine at a temperature of 180 degrees. So how are you going to do that? Well, this is how you do that. Okay, so let's go over them one by one. Now first of all, let's start out from sodium, group 3, period 3 element sodium. Sodium, when reacts with chlorine, it forms sodium chloride. Okay, the common table salt that you have. Sodium chloride is giant ionic lattice. It has an ionic lattice. Okay, it is giant ionic, and the flame color that is observed when sodium reacts with chlorine and it is burned and it is heated, the flame color is yellow. Okay, so when you burn sodium in presence of chlorine, you get a yellow flame color. Okay, and sodium chloride as your final product, which is a purely ionic compound. Why did I say purely? Because there are some compounds which have ionic plus covalent characteristics as well, and we are gonna look at them right now. Then magnesium, when it reacts with chlorine, it forms magnesium chloride and magnesium chloride. And by the way, the flame color is the same as the one which we saw with oxygen. Okay, a flame color is intense white flame, and magnesium chloride, this solid which is formed, it is a giant ionic compound with some covalent characteristic. Okay, and this is important because I did see an MCQ testing this concept, that which of these the following is ionic with some covalent character. So it's magnesium chloride. Now why does this have covalent character? Why? Explain. You don't need to go into that detail. Okay, for over here you just need to know the fact that yeah, this is ionic and it has covalent character. Sodium chloride is purely ionic, no covalent character. Then this setup is a laboratory setup. Okay, it was asked for like 2 marks once on the past exams, and once I think it was asked for 3 marks to draw the setup in which this reaction can take place. So basically you take a hard glass test tube. Okay, hard glass test tube, this is the key term that you use. Okay, the test tubes basically which you see in your school laboratories, the test tube, not the boiling tube, not the bigger tube, the smaller tube, the test tube, that's a hard glass test tube. Okay, its glass is very hard and doesn't easily break with heating. Now in this hard glass test tube, what you do is you put some metal. It can be magnesium, it can be sodium, it's up to you, and from one side you allow chlorine gas to pass, and from the other you allow excess chlorine to leave. Okay, and you heat this test tube from the bottom on this metal. So what will happen? This metal, whatever metal is present in this dish, it will react with the excuse me, this metal will react with the chlorine over there and will form sodium chloride or magnesium chloride, whatever you want to do. But the 3 marks over here, the first mark was for the labeling, hard glass test tube, labeling the metal and the chlorine gas correct. Then second mark was just for the representation. Okay, third mark, I don't think there was a 3 mark question, but there definitely was a 2 mark question on this. Then coming to aluminum. When aluminum reacts with chlorine, and this in fact is very important because there were tons of questions testing only aluminum. There was an entire question only on aluminum's reaction with chlorine, its extraction, meaning the question started out in the following way. They asked you about bauxite. Bauxite, remember your O levels, bauxite, ore of aluminum. That aluminum is extracted from bauxite, and then you have many uses, and it can react, it is a reactive metal and can react with chlorine. Write down an equation for the reaction of aluminum with chlorine at room temperature. So this is the first reaction that you have, and as soon as you change the conditions, the products will keep changing. Okay, now you take aluminum, react it with chlorine, you'll get aluminum chloride. And now this is a very important fact. Remember, magnesium chloride was ionic with some covalent character. Aluminum chloride is purely covalent. Aluminum chloride is purely covalent. Okay, remember this fact. Aluminum has 3 covalent bonds with chlorines. Okay, it is purely covalent. And if you look at the outermost shell electrons, there are just 6 electrons in the outer shell. 1 from chlorine and 1 from aluminum, 1 from chlorine and 1 from aluminum, and chlorine and aluminum. So there are a total of 6 electrons in its outermost shell. So this means that the aluminum has not followed the octet rule. It actually violated it and occupied fewer number of electrons in its outermost shell. In this case, we say that aluminum has an empty orbital and it is electron deficient, but it is still stable in this form. Okay, which is electron deficient. And by the way, remember the dative bonding concept. Dative bond can be formed with this AlCl3 as well. Why is this concept important? Because this will be tested in the A2 syllabus. Okay, aluminum over here, since it lacks one pair of electrons, one orbital is empty, it can accept a lone pair of electrons via a dative bond. Okay, AlCl3 such compound is called an electron deficient compound, and the octet has strength. Now I was saying that when aluminum reacts with chlorine at room temperature, it forms AlCl3 solid, and the color, the appearance of solid AlCl3 has also been asked on the past exams. AlCl3 is actually a cream colored solid. It is a pale white solid or pale yellow solid. Well, in the latest marking scheme it was written pale white, so therefore I would suggest you go with the latest marking scheme. It's pale white solid, okay, a cream colored solid basically. Then if you take these two molecules of AlCl3 which are produced over here, the solid molecules, and you heat them further, either you heat them further to 180 degrees, or what you do is you take the aluminum and chlorine and you take both the reactants and heat them directly at 180 degrees. Both will give you the same product, and you will get an Al2Cl6 dimer. Why is this called a dimer? If you look at the formula of Al2Cl6, it actually contains two molecules of AlCl3. This AlCl3, two molecules of AlCl3, when they combine by dative bonds, remember the structure of Al2Cl6, dative bonds, it contains dative bonds. Okay, in the covalent bonding chapter, in the dative bonding chapter, you must have seen that diagram of Al2Cl6. It contains two dative bond, one from the chlorine of this AlCl3 molecules to the aluminum of the other, and other dative bond from the chlorine of the other element to the aluminum of this molecule. But anyways, I'm not going into the structure, but it's called a dimer. Di means two, so two because it contains two molecules of AlCl3 combined together, okay, by dative bonds. Remember, there are two dative bonds within this molecule. This is also a question. Two dative bonds. Now, this Al2Cl6, this is produced when AlCl3 is heated to 180 degrees, and it's a gaseous compound, by the way. Now, this Al2Cl6, if it is further heated up to 600 degrees Celsius, the dative bonds will break and you will get two gaseous AlCl3, aluminum trichloride or aluminum chloride molecules. Okay, the dative bonds will break as soon as you heat it up to 600 degrees Celsius, and you will get two individual gaseous AlCl3 molecules. So now this flow chart that I have made over here, this would be good for remembering this these reactions easily. Okay, so first you've got aluminum and chlorine. You allow them to react together at room temperature. Okay, as soon as they react at room temperature, you get AlCl3 in the solid form, which is a pale yellow solid. This AlCl3 molecule, actually not one, you actually get two, because if you do the balancing, you get two molecules of AlCl3. These two molecules of AlCl3, when they are heated to 180 degrees, you get Al2Cl6 dimer. This Al2Cl6 dimer, when it is heated to 600 degrees, you get two molecules of AlCl3 back, but this time in the gaseous form rather than in the solid form. Okay, that's a solid S, and this is gas G. Okay, and this has been asked on the past exams. That's why I wrote important over here. Okay, all of these equations, every single equation from here has been tested. Even these have been tested on the past exams. Okay, so would really want you guys to learn these equations, and yeah, this completes the lecture. In the next lecture, we're going to talk about the reaction of chlorides of period 3 with water. Thank you.